Okay. All right, so we're gonna finish those last couple word problems, and then you will know how to do all this stuff. Right, that's your review. Here's your homework. I want. All right, so we did all of the areas, right? We did all of number 2. Is of all of these notes filled in? Okay, great. And I don't want to do number 7 or letter D. You definitely could do letter D. I just didn't do it with alpha. I just think that we've done enough of those types of problems. And it's a lot like the one we just did. It's a lot like C. So we're just not going to worry about D. We are going to do 3A and B. We're not going to do letter D. You definitely won't be accountable for. Letter C, I just didn't do with alpha. You can do it. I just didn't spend time on it because I think you guys are really getting the law of cosines, okay? So this is the law of cosines word problem if you want to do it later, but I really want to do these last 2 problems here. Number 3A is like one problem on the end of your 5.6 homework. So I want to make sure that we're good with that. Okay, it says find the area of a regular hexagon inscribed in a circle with radius of 12 inches. Okay, so if I have a hexagon inscribed in a circle, I've got a hexagon inside of a circle. So I'm going to draw a hexagon, and a lot of the reason I can do this is because Notability Magic is going to help me out, I hope. Come on, or not, let's see. There we go, okay. Notability Magic helped me out. You don't necessarily need to draw this, but what I do want to emphasizes the circle that goes around it. And again, I'm going to use some Notability Magic to help it look nice and neat. Keep talking and then it doesn't do it. Come on, there we go. So I need the circle to be outside of the hexagon. When it says inscribed, it means that the hexagon is inside, and it means that every point of the hexagon is on the circle. That's important to set up this problem. Find the area of a regular hexagon inscribed in a circle of radius 12 inches. Okay, so the circle has a radius of 12 inches. So that means halfway, half of the diameter is 12. I'm essentially going to draw all of these diameters that I can from point to point, because that splits up this hexagon into 6 smaller congruent triangles. And again, you can count them 1, 2, 3, 4, 5, 6. I'm going to erase that in a second, but you can count. You see, I have 6 little triangles here. The reason that is helpful here is because now I can just focus on the area of one triangle, and that if I can find the area of one triangle, I can multiply that by 6 because that's how many of those small triangles that I have. So I'm essentially taking one of those little triangles out of my picture. I just essentially blew this guy up so that I can draw on it. And it says my radius is 12. So that means all of these little lines in here are all 12. And again, you don't have to label all of them. The only ones I really need are those 2 right here. I know those 2 are 12. I actually don't know what this side is. I could find it, but I don't know it right now. But the last thing I do know, it's not maybe like super intuitive, but something that you do know is I know what this angle is right here. I know what all of these little angles is right here, and they're all the same. Tell me, how many degrees are in a circle?
360.
360. And how many triangles did I break that 360 degrees up into? 6. So I'm going to do 360 divided by 6, and that number is going to be 60, and that goes in that angle right there. And that's true for any shape. I could be a decagon and I would divide by 10 because there's going to be 10 sides, so there's 10 little figures. It could be a pentagon. I would divide by 5 because there's 5 sides, 5 little triangles. A octagon, there would be 8 little triangles because there's 8 sides. So whatever shape it is, we're going to divide that 360 by that number. Now I actually have enough information here to do the area of this little triangle. area, if you remember, equals 1/2 side times side times sine of the angle. So I'm gonna do 1/2 of 12 times 12 times sine of 60. So 1/2 of 12 is gonna be 6. So I get area equals 6 times 12 times sine of 60, and I'm just gonna go put that right in my calculator. 6 times 12 times sine 60. Now, one thing, make sure that you're in degrees. There's really no reason to be switching between degrees and radians here. You should just be in degrees. And I get 62.4. And that's in inches squared. Now, I am not done because that's just one triangle. The area of one triangle is 62.4. What's the area of the entire hexagon? Well, how would you do that? What's the math you did?
I just multiplied that by 6.
Good, because there's 6 triangles, so we're gonna multiply the area that we get times how many triangles there are. So I'm gonna do 6 times 62.4. And I get 374.4. All right, I would expect to see one like that on your quest tomorrow. I would expect to see one on your homework. I would expect to see one on your review guide. So I'm trying to set you up with success with a lot of these different examples. Okay. All right, let's do the last one. It says a parallelogram has sides 18 and 26 and an angle of 39 degrees. Find the shorter diagonal. So let's draw ourselves a parallelogram. So it looks something like this. You remember all the way back to years and years ago when I taught you geometry, all that we know about a parallelogram is that the opposite sides are parallel. We know opposite sides are congruent. We know opposite angles are congruent. We know consecutive angles are sub. We know a lot of things about parallelograms, but what I want to do is kind of draw it in a very traditional parallelogram shape. I'm going to label my sides 18 and 26. Can I label any other sides if I know that those two are 18 and 26?
Yeah, which side is the same?
Good, my opposite sides are congruent, so both of those are 18, both of these are 26. And then it says we've got an angle that's 39. Now I know that this isn't drawn to scale, but in a parallelogram, you've got one angle that's acute and you've got one angle that's obtuse. So I'm gonna put the 39 in the acute angle spot. So 39 goes there, and I can also put it over there. Now it says find the shorter diagonal. One thing that my geometry kids always struggle with is just knowing the facts about parallelograms versus rectangles versus rhombuses. In a parallelogram, your diagonals are not congruent. So one diagonal is going to be longer or shorter than the other one. Which one that I drew is shorter? The first one that I drew or the second one I drew? Is it this one or is it that one? Which one's shorter? The first one, right? I'm also going to give you a hint. It's across from the 39 degrees, so that's got to be a shorter number than the one that's across from this big obtuse angle, okay? So my shorter diagonal is this guy right here. And it says we want to find that. Could we figure out using either law of sines or law of cosines or the area formula how to find that x? Which one do I want to use? What'd you say? I don't think law of sines. We would do cosines here. Do law of cosines. I would have the x all by itself. So we use law of cosines every time that we have side, 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 and side, angle, side. Side, 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 and side, angle, side is law of cosines. And I have a side, angle, side, so I'm going to do that. So I'm going to say x squared equals 18 squared plus 26 squared minus 2 times 18 times 26 times cosine of 39. And this is actually one of the easier ones because, I can almost just plug everything in on the right side into the calculator and go from there. Bless you. Now, I have PTSD of having an old calculator, so I'm super careful and I'm gonna do every step out. But I think you could literally put all of that in as long as you have the right parentheses and right pluses, minuses, all that fun stuff. I combine all of those. Oh, I have too many threes up there. So x squared is gonna equal 676.71, square root both sides. And I get 26. Right, that's really all I wanted to do with you guys today. So we've got a little bit of time before lunch. I want to work on that 5.6 homework. I will also pass out your reviews if you want to start working on those. After lunch, we'll kind of see where we're at, see if we need to go over any homework, but I want you to try and get that homework finished and done in class, and then the rest of the time is gonna be review for the quest. Okay.